Hi, it's Phil Chambers with another in the series of talks on health and safety topics. I hope you're all keeping well with the COVID-19 issues, etc., and are coping with lockdown and all the other control measures in place. This was a talk I gave to the Bristol and West branch of the Institution of Occupational Safety and Health a couple of years ago on machinery provision and use of work equipment regulations and CE marking. It might be thought of as being a bit of a stodgy subject, but I've tried to keep it as interesting as I can, and most people found it like that. Found it to be interesting. If we look at this the way I've represented this, the obligations on the manufacturer on the left and on the employer on the right. Obviously, we've got obligations under the Health and Safety Act, Safety at Work Act, for both the employer and the manufacturer. But then we've got the provision and use of work equipment regulations, which is on the employer, and then we've got the supply of machinery safety regulations, which is an obligation on the manufacturer. There's a considerable amount of overlap between those two, by the way. Where does the final obligation or final accountability end? Well, it seems to be with the employer there. And I cite the example of the London Borough of Tower Hamlets, which is HSBC Bank PLC, something which happened, I don't know, about 20 years ago, but I was personally involved with. It may seem strange that it's, we're talking about, excuse me, we're talking about a local council, but it was because this was a shared building. The majority of the building was offices, so it came under the council rather than the Health and Safety Executive. And HSBC had bought this baby web-fed press from a Spanish company called IMA. They'd had it a month and the guy lost a finger in it. Now I should stress that this person here who's demonstrating this is operating completely safely because we isolated this machine before he showed me where this person had put his hand and got it caught in running nips between rollers. They didn't need to be exposed, they could be guarded quite easily with a fixed guard, which is what IMA put into place afterwards. But the case was taken out against HSBC mainly because it was easy to do that, much easier to prosecute a British organisation than it was to prosecute a Spanish organisation. I was in the unfortunate position where I'd been asked to investigate this machine by HSBC and give my views on the design standards of it, and my report was then used by HSBC, by Tower Hamlets Council in the case they brought against HSBC. And I was instructed as an expert witness. Fortunately, it never got to court. They pleaded guilty on the Friday afternoon when the court session was supposed to be on the Monday. What's safety and what is reliability? Safety, in my opinion, is the prevention of hazardous situations occurring. And reliability is the confidence that those measures put in place for safety reasons continue to do their job. When I started driving, which was a long time ago, about 50 years ago, cars had single circuit braking systems. That is, you put your foot on the brake pedal and that acted on the master cylinder, and hydraulic pressure went through a single pipe, split four ways, to the cylinders on the individual brakes. If you had a leak in that system, then you lost braking completely. You only had the handbrake and your faith in the Lord to stop you. What happens these days is that cars have dual circuit brakes. That is, there's two circuits. If you get a leak in one circuit, then the other circuit continues to operate, and it will apply pressure to the brakes. Furthermore, it actually compares the pressures in the two circuits, and it says that we've got a leak in one circuit, so that will bring up a light on your dashboard, and that won't go out until you've had it rectified. Were the brakes in the olden days unsafe? No, they weren't. Were they less than reliable? Yes, they were. So reliability is the confidence that we've got to actually the brakes to continue to work. Reliability in safety devices is prevention of failure. Is the first thing. Is coping with failure. So the braking system would actually cope with one system failing and would keep the whole braking system working. But it also will tell you that something has failed, because it's pointless having a dual circuit or redundancy in any kind of safety system unless you actually know that the failure has occurred. If you don't have that, and it's the same as having, and one system fails, you've still then got a single system that's left, and you don't know what's happening. Reliability can be measured in probability of failure, or more commonly, the mean time to failure. Now, the difference between pure and CE marking is that both require safety, but CE marking requires reliability as well. The common misconception is that existing machinery doesn't require bringing up to present standards. That's not quite true. Existing machinery must meet the requirements of pure. You can't get away from that. But you don't have to bring it up to the standard of reliability that CE marking requires. Here's an example. Now, I should stress that this is a machine which is being built in the factory run by Formit. So Formit are the manufacturers of this machinery, and they are the cream when it comes to controlling machinery. There's no issues. So this whole machine would actually, when it's installed in the client's factory, would actually be a controlled environment. Predominantly a cage, sometimes light curtains in certain places. But what we've got here is the way that these machines work is there's a strip of steel that comes off a coil and goes through along there, and it goes through these rollers, and these rollers have got profiles on them that gradually change the shape of the steel as it goes through. In-running nips there galore. If you get your hands in there, then you haven't got a hand afterwards. Certainly you're losing several fingers. Now, I was doing work for Formit. I helped them with their CE marking, and I was looking at was providing support for them on a machine which was being installed at a company in Wellingborough, and there was nothing wrong with that machine at all. The excellent guarding in place, fixed guards, interlock guards, light curtains, whole combination was appropriate. But next to it was another machine which was like this, completely open, an older machine. Not necessarily a Formit machine, by the way, but an older machine doing the same kind of thing. And I said something along the lines of, good heavens, or maybe a bit more forthright than that, but that needs guarding. And somebody said, well, we don't have to bring it up to the same standard. Yes, you do need guarding because of pure. You don't have to bring it up to the standard that's required by CE marking. Right, provisional use work equipment regulations have got various clauses in them, and we've got something which is, it's nothing unusual there. It's obviously got to be suitable for the task that's got to be done. If it requires maintenance to keep it safe, then you've got to have a written system of carrying out maintenance. Similarly for inspection, if it requires inspection to keep it safe, then you need to do that. Obviously, controls down here for stopping, starting, etc. And then we've got a whole load of things about isolation. You've got to be able to shut the thing off and lock it out if need be. And then these last things were put in at the last revision because of issues we had over forklift trucks overturning, etc. Now, Pure makes no requirements for an assessment. You occasionally get people trying to flog me their services, trying to say we carry out Pure assessments as required by the provision and use of work equipment regulations. It makes no requirement whatsoever for an assessment. You've got to comply with it, so it would be a good idea to actually review the equipment to make sure that you are compliant, but it makes no requirement, doesn't actually say there is an assessment required. There's lots of things that you can get caught on in machinery. In-running nips is a common one, between two rollers running in towards each other, or something like that. So you've got a roller going round and you can draw your finger into it. Entanglement, crushing, etc., shearing, all of those things like that. Kind of risk controls that you've got is Pure 11.2a puts fixed guards as the primary control, and then you've got other things afterwards. I would actually say that, or some people would argue that proper interlock guards are preferable to fixed guards. Don't know about that. You can argue with that. Certainly, fixed guards are only suitable for those things which you never need to get into, or you only ever need to get into them for maintenance reasons. So, for example, let's say you've got a belt that goes between pulleys, and you occasionally need to change that belt because it gets worn. You have to get in there every couple of years or so and do that. Fixed guard is perfectly adequate for that, providing you isolate the machine before you take that guard off. You take the guard off, you do the maintenance work, you put the guard back on again, and that allows you to run the machine again. I would put these things in order. These are my, if you like, sequence of things. Interlock guard, a physical guard, that's something that you can't actually get through. An active or presence sensing device, so light curtain, pressure mats or something like that, they don't actually stop you getting to the dangerous bit. They would actually do something if they did sense you, and they would stop the machine, or normally stop the machine before you get there. Two-handed control, that's one way. You've got to press two buttons at the same time. That's another method. But remember that two-handed control only controls the risks to two hands. So if you've got more than one person there, then it's not an adequate control system. You've either got to have some other way of doing it, or you've got to have a system of work that keeps everybody else away from there. Trips, adjustable guards. Trips are things that if you actually get there and move something, then it will stop the machine. And the interesting thing is, with the latest version of Pure, it's put "and information and training." With the original version, it said "or information and training," but now it requires the other things before you actually get to information and training. Interlock guard is a movable guard with a switch, interlocked to the machine control system. And when the guard is open, the machine is normally stopped, or it's forced into some other movement, restricted movement, either inch or control. Switches should operate in the positive mode rather than the negative mode. And what we mean by that is this. This is the negative mode. We've got a spring within the switch itself. And when you open the guard, I'm showing this as something which is slid open, then the spring in the switch will open the contacts in the switch, break the circuit. Obviously, it relies on the spring being managed to do that. And if the switch is gummed up with some kind of muck or something like that, you've got the possibility of it not opening. Also, if somebody smacked their wrists, but if somebody puts tape over it and tapes the switch closed, then you can open the guard and the machine can still run. The positive mode is different to that, in that when you open the switch, open the guard, the contacts of the switch are forced open. It's a direct movement of the switch, and the spring in the switch is the thing that actually closes the switch when you remove the guard, when you actually slide it closed again. So it's a much better way of operating. You've got to be wary though. This is a machine at a company in South Devon. I can't quite remember what it does. It's part of printing equipment, but it's perfectly safe because it's got this guarding around it, these plastic screens that stop you getting in there. And if you look at this thing here, to open it, to get into it, you slide this guard, this centre one. If you look at it, it's got a switch operating in the positive mode. We ignore the fact that the guarding is rather broken, but we've got a contact on the interlock switch just there, which pokes through a hole when the guard is closed. So that's operating in the positive mode. So as soon as we slide it one way, that way, then the contacts will the guard contacts that switch, forces the contacts of the switch open and stops the machine. Don't know if anybody can spot the downside to that, to this arrangement, and that is if you switch it the other way. Oops. Sorry about that. If you switched it, if you moved it the other way, then again it will shut off the machine. But then effectively the switch will be operating in this region of the guard, and it would think that the guard is closed. That's obviously an unsafe situation, and we quite simply got round that very easily by at the other end of this track we just put a bolt through there, poking out through there, which stopped you moving in this direction. You know, it's a 20-pound solution to it. These are interlock switches, lots of them about. These types have a tongue which fits into the switch, and they physically break the contacts in the switch. When you pull that switch out, pull the switch apart, it physically breaks the contacts within them. This is an interesting one. It's a combined hinge and switch. The only downside to it is it's only got one pair of contacts in it, so you've got to buy two of those to give you the required redundancy if you've got a dual switching system. But you're going to need two hinges anyway, so it's not a lot different. Here's an arrangement where we've got this guard, which when you pivot it about this shaft here, it will force open the contacts in this switch. This shows that arrangement here, but you've got to be aware of that, because this is the guard here, by the way, this mesh thing that pivots about this shaft. It's on a Mark Andy roll label printing machine, and I don't have the confidence that cam is going to contact that switch. It might just about do it, but it doesn't look like it. So you've got to make sure that it does actually contact that switch. And here's another piece of machinery, again with a cam and a switch just there. But this shaft can, this guard here can slot from side to side. Bit of a sloppy thing there. And if I moved it to this far left direction, which is what I did, it would the cam would no longer engage that switch, so it wasn't actually operating. We have to put in a little packer piece in there to stop you moving in that direction to get around that problem. It didn't take very long, just a bit of angle line that was just bolted in, but it's something you've got to realise. Now, the first rule of mechanical guards is they must be practicable. And this was a company up in Clitheroe, around that area, somewhere in Lancashire. And they'd had a visit from the HSE, and this machine makes, this company makes very complicated components, predominantly for Rolls-Royce. So the big fans that you've got on the front of Trent engines, whatever, are made by this company. But they've got a couple of little machines like this in a corner, and the HSE said that it needs guarding on it. So they put this interlock guard in there. And you cannot operate that machine with this guard closed. So it's a totally pointless piece of guarding. It is totally useless. Now, this bit is something you would never get in any textbook. I don't know why, but nobody's ever written this down. But I believe that there are three general categories of mechanical guards: immediate, local and perimeter. Now, immediate is something just right at that point. You notice that guarding there, it stops you getting your fingers into that danger area. Local is something which is far more common and preferable, and that's to have a guard around this whole thing there. And then perimeter is you put a guard around the whole machine. Now, local is by far the most preferable of the three alternatives. Immediate, you've got to be very careful about the kind of hazard that you are guarding. If it's operating very quickly, then that won't do any good at all. With perimeter, which you might get with, say, an injection molding machine, with a robot unloading that machine and putting it onto a conveyor which goes out for a tunnel guard, that's great. But if you need to get in there and do anything, perimeter is useless. Now, here's an example of an immediate guard. We've got this in-running nip here. You don't need to have two rollers. It could be between one roller and a fixed surface. And the way to stop you getting your fingers in there is to have this fixed guard here, fixed immediate guard. It's got to be at 90 degrees. You can't have a wedge shaped guard, that's useless. And the requirements are that it should be, of the guidance, you won't find it written down anywhere, but the general rule of thumb is that it should be 6mm maximum, because you can't get your finger into a 6mm gap. Now, be very careful with this when you start to say that, because you've got something like a rubber roller, then that will deform and can get your fingers in there. And I had an accident with a company down in Southampton where somebody got his finger wedged in a 3mm gap. Now, you try and get your finger wedged into a 3mm gap, it's very, very difficult. But if you've got a rubber roller which deforms, then you get your finger stuck in there and you can't get your finger out. There's a variation on an immediate guard, which is this, and that's fine. No problems with that at all. You can't get your fingers in there, and that's great. But what you mustn't do is then do this kind of thing, which is you're just shifting the problem from there round to there. It's a poor design of guard. You've got to think of what you're doing with the guard when you put it in place. It's not only the primary control which is there, it's the other thing. These are our perimeter guards. This was a company in south east London quite some time ago, and they made graph paper, and you've got this continuous web of paper that's going through it, and it's printing the kind of paper where you get kind of fan folds or stuff that enable you to record what's happening in some kind of process, temperatures or what have you. And they've been visited by the HSE, and the HSE said you need to guard this machinery. So they put these perimeter guards on. They put this on this side here, and another one on the other side there. They screwed up because they hadn't got this this shaft here covered. It's ridiculous. But then they found that they needed to get into these control knobs down here, and they couldn't get into it because the guard was in the way. And so what they've done is to cut away the guard to enable them to get in there, and that means you can still get to the dangerous in-running nips. And they asked my advice on what you could do with that, and I said, well, first of all, you throw away this whole thing. We cover that shaft up, obviously, but we just guard that particular dangerous area down there, and which allows you to get into everything else. A bit more difficult to design, but much better than an effective perimeter guard. Similar thing with a company in London. They made stationery, and they had two lines, one of which two lines for producing suspension files, the things that you stick your files into in a filing cabinet, with a little metal thing on top with hooks at the either end. And this had a perimeter guard in it, which went all the way along, but you'll notice in this bit the perimeter guard is up, and it was operated with the interlock overridden for all the times that it was operating. And the guy that showed it to me said, well, I broke my finger in that bit, and I broke my wrist in that bit around that. It was a terrible thing. But you had to get into it to actually view what was happening around here. These are the metal bits that were being fed in. And what we did was we built a much closer guard, so you could actually get into there. This was all interlocked, of course. We had to. This was just before we moved this thing outside, by the way. That the controls moved outside after we put this in place. But you could lean on this and look at the feeding which you needed to do quite safely. Comments on how guards fail. Obviously, the first one is inadequate design. It's gaps of two lines, you get your fingers through or whatever. You can take the guard away. Fixed guards require tools to remove them, but it also requires a tool to replace them, and there's no robust snap fixing on the market. You won't be able to push the guard back on again without needing a tool, but there's not a lot of stuff on the market that's really suitable. You can override the interlock, taking it down, and you can do things there. The interlock itself can fail, stuck on welded contracts, or there could be downstream equipment or glitch in the PLC. We'll come to that later on. Active devices, you've got all of these things. Light curtains, pressure mats, I don't think they are as effective as a physical barrier. You can't use them if the reaction time, the time to stop the machine, is less than the time that it takes to approach the danger area. So if you're just putting your hand through a gap, then the machine has got to stop pretty quickly. You can increase the approach time by putting the light curtain further away, but then you've got to cope with people being inside that area. So, for example, this is the kind of separation distance. This is one way on a metal press brake where they increase the separation distance, but then they put this other horizontal light curtain which will actually detect that somebody's standing in that area there. So if you didn't have that, you could break the light curtain and be inside that area, and the machine could then start up because the light curtain is no longer broken. You must have adequate stop in the emergency stop controls and methods of isolation when accessing dangerous areas. You can't rely on interlock switches, and you need an isolation and possibly lockout method. So a lot of isolation switches would actually have a hole which you can put a lock through to actually stop it being operated when you're in the position of danger. CE marking applies to machinery put into first time service after the 1st of January 93, so quite some time ago. It was originally intended as a trading tool between the EU member states So the idea was that if you made a machine here and you exported it to France, for example, then the French would accept it as being compliant and they wouldn't have their own set of requirements put on top of that. So it was really a trading tool between the member states, but it says suppliers are put into service. It did the original regulations actually says with a bit more stronger wording, which actually said that the person who supplies or puts a machine into service or makes a machine for himself is regarded as a supplier. But basically, if you supply or you put machine into service, even equipment for self-use requires CE marking. Now, if you obtain machinery from outside the EU, which has not been CE marked, then you become the supplier. So you've got to be very careful with that. And even if it's an old machine, a machine built before the 1st of January 93, if you bring it into the EU now, then you must bring it up to the present standard. So what you've got to have is you've got to have some in your purchase contract, something that says that the supplier outside the CE, you must bring the machine CE mark machine up to the appropriate standard for CE marking. They must be the CE marker, if you like. Now, I've heard people say, and this was a pitfall of or what caused the HSBC bank problem. They said, oh, it must be safe, it's CE marked, and it wouldn't have passed the marking of the CE inspector, or the inspection of the CE inspector. But there's no such person. Yes, there is, if you're talking about plastic injection molding machines, woodworking machinery, things like that. But for most machines, there's no CE certifier. It is a self-certification process. The final accountability is with the users of the equipment. So always suspect that equipment from outside the EU may be dodgy. Requirements of CE is to design and build the equipment so it complies with the essential health and safety requirements specified in the supply machinery safety regulations or harmonised European standards. The supply machinery safety regulations, by the way, is the UK's equivalent of the machinery standard, or the machinery standard of the EU. Every state produces a machinery directive. Each state produces their own regulations from that directive. You must build it, and so it complies with that. You assess the equipment for conformity with those. You must be able to compile a technical file proving conformance. You don't have to provide a technical file, but you must be able to provide one, compile one if requested by either the client of people who are putting that machine into operation, or by the HSE. And then you draw up a declaration of conformity and you fix the CE mark to the equipment. There's a few things in there I'll just draw your attention to. EN 13849 is the standard for safety related control systems. It's very user unfriendly. It's obviously a standard which has been put together by a committee of people who didn't like each other, and they've got various fixed ideas, and it zigzags backwards and forwards between different approaches within it. So what I've done is created white paper 4, which you can get from this particular page here, the Strategic Safety Systems publications page, and you can download that paper, and it tells you how it's much friendlier than the standard. But what it requires you to do is to calculate the required performance level for each channel depending on what's going to go wrong. So the severity of the injury, the frequency they're exposed to the hazard, and the possibility of being able to avoid that harm. So you start there, and it may be that you've got a reversible injury, which would take you up to S1. You've got frequent exposure, which is F2, and it's possible to avoid it under specific conditions that would take you up to a point, a PLR of B. And that would say that different ways of actually meeting it are controlled by that. So if that's the PLR there, then you could use a category B or category 2, etc. So these are much higher standards of control systems as you go along. I strongly advise you, in fact I would say more than strongly advise you, never ever do this. You can have a high reliability interlock and emergency stop switches, so we've got maybe dual circuit interlock switches and emergency stops going into a relay, a PILTS type relay. Other manufacturers are available, a high integrity relay. But if you you've then got a high integrity interlock system there, and then you stuff it into a PLC. Now, PLC, programmable logic controller, you've got no control over what the program is within that. So if it's a standard PLC, you might run into trouble there, and so you must never do this unless the PLC is a safety related type designed for doing this kind of thing. We draw you to this example. This was a company in Plymouth, and this was a laminating machine. There was a guard here with an interlock switch just at that point. It's hinged about this point, and there's a nip in that area there. So materials comes along here, it goes round this through this roller here, which is rotating anti-clockwise, as shown in this view. And what happened was the machine got jammed up. It took too much material through, and it stalled. And the operator had done nothing wrong whatsoever. He hadn't overridden the interlock switch or anything, but he opened it up here, and as he freed the material, the machine started up again, and he caught his hand in these rollers here. Not a serious injury, thankfully, but he caught his fingers in there. And the question was asked, how could this happen? Because it's got an interlock on there, he must have been doing something wrong. He must have overridden the interlock, otherwise the machine couldn't start up. But when I looked at this circuit diagram for the machine, you found that the interlock actually went into the PLC as a feed there, and it was quite obvious that the PLC was busy doing something else, waiting for the next part of the program. And because it was paused during that, it couldn't actually provide the safety function. So as soon as he got rid of this blockage here, it continued on its way, and took no notice of that. So you mustn't ever do that. And just this thing about what's happened because of Brexit. CE was a trading standard between countries within the European Union. Because of Brexit, we've got this confusing situation now, which isn't in place yet. By the way, it's supposed to come into place at the end of this year. Whether it will, I don't know, because I suspect because of COVID-19, this may be put off. But we're going to have this mark. It would be exactly the same as the CE mark, exactly the same requirements. So if the machine was built in the UK and it was being used in the UK, then it would have the UK CE mark, that one. However, if we were exporting it to the EU, then we still have to have the CE mark. Now, if it was starting off in the EU and coming into the UK, I don't know what's going to happen. I don't think that they are, countries would be putting the UK CE mark on. I think they'd be providing a CE with a CE mark. I've got no idea. Obviously, countries outside the EU and the UK providing equipment to the EU, they require the CE mark. But then the countries outside the EU and the UK providing providing machinery to the UK, will they be required to use the UK CE mark? I've got no idea. Nobody knows. Nobody can tell you at the moment. It's up for grabs. Well, that's the end of this talk. I hope you've enjoyed it. I'll leave you with his contact details, phillipsstrategicsafety.co.uk, or my mobile, which is 077 11667, if you need to contact me. Be delighted to hear from you with any kind of comments on this talk. Right, thank you. Bye.